An open top box is created by cutting out squares of side length x from each corner of a piece of cardboard and bending up the sides. The cardboard is 18 inches by 24 inches. What is the maximum possible value of the box? The first step when solving any type of these problems is to assign variables to unknown quantities and draw pictures. Well, we're creating a box from a rectangular piece of cardboard, so let's start by drawing our rectangle. We know that it is 18 inches by 24 inches, and each corner is going to have square cutouts, and then we'll be bending in between the corners to create our box. And since we're making a box and figuring out its volume, we have to determine what the length, width, and height will be from this box. So we have this width right here of 18, and we're subtracting an x from this side and an x from this side. So we'll end up having a width 18 minus 2x. Similarly, the length that we have here is 24, and we're taking away an x on this side and an x on this side. So the length in the volume will be 24 minus 2x. And the height of our box will end up being that x value that we cut. So the next step in solving this problem is to define the constraints of our variable. Well, we know that the width and length of a box cannot be negative numbers. And both of these expressions are subtracting a 2x. So let's use our width equation or the expression for width, to set up an inequality here. So we have that 18 minus 2x must be less than 18, but also greater than 0. Because if the x value is 0, we would be at 18. Well, it can't be that. You still have to cut something out. That's why it's less than. But it also has to be greater than 0 because you cannot have a 0 or a negative side length. So now if we were to solve this inequality for x by subtracting 18 to all sections, we would get negative 18 is less than negative 2x, which is less than 0. And then from here, if we divide all of our terms by negative 2, all of our inequalities would flip around, and we would have also number sign changes. So we would have positive 9 is greater than x, which is greater than 0. In other words, we would have that 0 is less than x, which is less than 9. Next, we need to determine the equation that needs to be maximized or minimized. And we're trying to find the maximum possible volume. Okay, so we need to find the volume of our box. Well, the volume of any rectangular prism or box is length times width times height. And now we can also put them all in terms of one variable because the height is x, the width is 18 minus 2x, and the length is 24 minus 2x. So if we substitute all these values in, we will get this expression, x times 18 minus 2x times 24 minus 2x. And now from here, we need to multiply all of these together. Let's first start off by multiplying these two binomials together. So we can rewrite the volume equation as x times 18 times 24 will give us 432. We'll have minus 36x minus 48x plus 4x squared. If we combine our like terms together, we'll end up getting negative 84x, and we can rearrange these and put the highest degree as our first term in parentheses. And then if we distribute this x through to those terms, we will end up getting that the volume is equal to 4x cubed minus 84x squared plus 432x. Next, we're going to take the derivative of our volume equation using the power rule. So we'll have 12x squared minus 168x plus 432. And then we're going to set it equal to 0 in order to determine our critical x values. And there are a couple of different strategies that you could use to find the zeros of this derivative. For example, you could graph the quadratic and use the zero commands of the calculator to find its zeros, or you could use the quadratic formula. I'm going to actually utilize the graphing calculator and finding zeros option. So here's what the graph will look like. And if we click on it, we have these two zero values. We have x is equal to 3 and 394 thousandths, and we have 10 and 606 thousandths. Well, if we look at our constraint within our domain, this 10 and 606 thousandths are not within it, so we can exclude that value. And now that we know which solution works, 3 and 394 thousandths, we can use the second derivative test and figure out what v double prime is. So let's actually do that work up here. So we have v double prime will be 24x minus 168. And if we substitute 3 and 394 thousandths in for x, we will get negative 86 and 544 thousandths. It's negative. That means that it is concave down, and it will produce a maximum value that we're looking for. So therefore, we can then substitute this value into our volume equation here to determine what the maximum volume value is. And when we do substitute our x value into that formula and evaluate it, we end up getting that the volume is 654 and 977 thousandths cubic inches, or answer choice D.